Okay, thanks, Tim. So Vermilion River in this case is spelt with one L, and it's a river in central state of Illinois in the U.S. And I think, as I recall correctly, there's a Vermilion River with two L's in Alberta, so we're talking about the one in the U.S. So what was Vermilion River Observatory? Well, from 1959 to 1981, the University of Illinois built and operated telescopes at this particular place, which the University of Illinois is located in Champaign, Illinois, which is about, I guess, 180 kilometers, or anyway, about a 2-hour drive south of Chicago. When you get there, if you drive about 60 miles for about another hour east, you hit a small town near the Indiana border called Danville, and then you go about 10 kilometers or so southeast from Danville toward the Illinois-Indiana border. There's a river there called the Vermilion River. And as we'll see, that some of the characteristics of the area made it very useful for designing a radio telescope. Now, the chief designer and the main subject of this talk is an individual called George W. Swenson, Jr. For those of you younger than about 50, George Swenson is known probably principally the author of this massive tome called Interferometry and Synthesis in Radio Astronomy. And I'm sure he made quite a large contribution to it, but this was after the time I knew him, etc. So I'm more interested in here. Swenson had a very eclectic career he was a very good electrical engineer, as we'll see. But he also had a wide range of research interests, some relating to Canada. He actually participated in an experiment studying the mosquito population in northern Canada, of all things, which where he was actually a pilot, so he helped somebody in the biology department going around studying the mosquito population in northern Canada, which probably most people who are Canadians here are sort of familiar with. And his other research interest ranged as far as actually studying the propagation of sound through gravel, the stuff we put on roads, etc. So in between, he built radio telescopes, and he's also the person who brought the VLA to you, because he was the main head of this VLA design group in the mid-1960s, who came up with the design of the VLA as we know it today, as well I'll mention. Okay, so what was happening with the telescopes that George Swenson actually built? First one was actually a giant 400 by 6 foot parabolic dish oriented north-south. And I'm going to say actually that this telescope was a chime precursor. So that's this Canadian relationship, because as we'll see, some of the characteristics are actually echoed in the chime telescope, although I'd be surprised if anybody from chime ever read the papers on designing this telescope. Also, there's two people who got degrees from the University of Illinois which had relationships directly or indirectly with some of these telescopes. We actually have an honest-to-God user of the 400 by 6 foot, 100-foot telescope right here in the room with us, John McLeod, who got a degree from the Electrical Engineering Department in 1964, and I got a degree from the Astronomy Department in 1972. And I actually used the 120-foot telescope for some science, but not a whole lot. I never had anything really to do with the 400 by 600-foot telescope, although when I was considering where to go to graduate school back in those days, you went and wrote letters to astronomy departments and said, what do you do? And that 400 by 600-foot telescope was a very good PR attraction, even though at that time it was already sort of falling, I think a little bit by the wayside. Okay, so where can we, did I miss one here, maybe? Oh yeah, no, okay. Okay, so I also figure I've just founded the subject of radio astronomy archaeology, because you all know that when you can look at Landsat or even Google Map images or whatever, you can actually see whether something's been there in the past through changes in the color or the intensity of vegetation, etc. And actually, somebody recently claims they found a new Norse village on the southern coast of Newfoundland by seeing differences in the sort of rectangular structures from Landsat or some kind of space-based data. So when you go down to southeast of this town of Danville and you hunt around on Google Earth, what do you see? You see there's this sort of lighter color in the vegetation there, and there's this road going along here. There's another little structure up here. This is the remains of the 400-foot by 600-foot telescope. So here's your scale, 600 feet by about 400 feet. So roughly, depending on how much you like to do, measure basically at 4 soccer fields or 4 football fields in size. And up here is the remains of this other telescope. There's the 120-foot telescope. Okay, we can zoom in a little bit more detail. There's still this building left over here. And here you can really see there's this change of vegetation in the area of the 400 foot by 600 foot. And here's a zoom in on the 120-foot telescope where looks like there's some kind of concrete pad left behind, but the telescope itself is gone. Okay, so what was the, Jasper Wall gave a really good introduction yesterday to the whole radio astronomy cosmology problem back in 1956. Cambridge guys didn't like Fred Hoyle. And the Sydney guys say, well, we didn't agree with Fred Hoyle either, but we don't agree with the Cambridge stuff. So there was real quandary there. Now, the head of the astronomy department was an English guy named George McVitie, who was actually one of these people who did theoretical cosmology and theoretical general relativity, and that basically meant you were sort of messing around with metrics and manifolds and that sort of thing. But somewhere along, he was very aware of the source count problem, so he actually, he was head of the small astronomy department there, and he decided he was going to build a new radio telescope to investigate the problem. They had to find somebody to build it, and I won't go into the background details, but he convinced George Swenson, who was then at the University of Michigan, to come over and join the department. And so Swenson joined the department in, I think, late 1956. And I just say how good an electrical engineer he was, because on October 4th, 1957, Sputnik 1 got launched, and that was kind of one of the seminal events of mid-century, 20th century, both science and society, et cetera. It was a real impact in Western society. Swenson had some graduate students from the electrical engineering department build a radio interferometer in about a day and a half so they could actually get more precise positions for this thing, et cetera. Anyway, he didn't know much about radio astronomy, so he spent 2 years learning about what radio astronomy was, and he was told to design and build an appropriate radio telescope to look at this cosmological problem. So the solution that he came up with eventually was a 600 by 400 foot fixed parabolic trough with a focal to diameter ratio of about 0.69, which meant that the focal point of this telescope was a catwalk, somewhere I've got it here. Yeah, a 425-foot feed platform. It has 274 conical log spiral circular polarized antenna, but that platform was sitting up at a height of 165 feet above the ground, so about 45 meters, something like that. So it's quite a long way up. I've got to move along here. Okay, anyway, basically, Mike Kesteven pointed out in his the design of the Malongo array that you had this mechanical system which changed the phase. With the 600-foot, this was done much more economically by human graduate students. And John McLeod was an outstanding example of that. So what you had to do is you had to take a homemade elevator designed by George Swenson up to this 665-foot platform and crawl along with a piece of paper manually adjusting the phase of these things to steer these things to some particular point on the sky. And unlike CHIME, for example, which is going to have about 1 bazillion data points coming out of it, this telescope had just exactly one beam of about 16 arc minutes with an N sensitivity of about 1 Jansky in a single drift scan. Okay, two people who helped Swenson a lot in these things were he had mechanical engineer Arno Schriefer. Let's see, okay. Weather would like my current location. Touched the wrong button.
I don't know what happened.
There we are. Yes. Okay, so anyway, these are two people. There's you can actually look through the literature. There are papers by these guys describing the detail at sort of professional level. Anyway, back in those days, as Rob Roger mentioned yesterday, once you got money for your telescope, you didn't have to go through all sorts of bureaucratic thing and environmental tests and blah, blah, blah. You hit the ground with the bulldozers and you started bulldozing. Because the river here, there was actually a river going through this. It was a small tributary of the actual Vermilion River, which is a little bit south. But anyway, he was going to have this fixed parabolic cylinder, and they found this gulch southeast of Danville, Illinois, and when the money came through, the bulldozers hit the dirt and started shoveling dirt around. 2 minutes, got to go real fast here. Okay, so here's this thing being built. Here's your 165-foot tower. Here's an indication of the size of this thing by various human beings wandering around. It was big. And now one thing, this telescope was considered an important telescope at the time because all sorts of big shots showed up and got their photos taken. Here's our head of the department, G.C. McVitie, Hanbury Brown, Rudolf Minkowski, one of the famous early optical observers of various radio sources, and George Swenson here. Visitors number 2, here's Bracewell and Swenson actually made a trip to Russia to look at Russian radio telescopes in the early 60s. So Bracewell showed up to have a look at this thing. Miller mentioned Joe Pawsey earlier. Well, Joe Pawsey showed up too. Apparently, I don't know whether Miller mentioned where Joe Pawsey was everywhere else, but in September 1961, Joe Pawsey showed up here and was helping roll out some of this mesh, or actually rolling up some of this mesh, because one of the things they hadn't accounted for properly was the fact that occasionally in the spring you got heavy rains and these rivers came through, and they actually had to build a little dam upstream eventually to avoid this kind of erosion. But so I'm not sure how long he was helping the hand for. And here's this picture of some of these conical antennas. Here's this picture of the finished telescope, and there's this building here, I guess, was the control building for the system. But the irony is that the department never really hired anybody who really wanted to be doing source counts. So I ended up being, ironically, the only person who ever presented a 610 megahertz source count, and this was from Westerbork data at an IAU Symposium 74, which probably Jasper must have certainly attended back at Cambridge in 1976, I think, anyway. So this is the ironic thing, that this telescope was going to go down to one flux unit, and still, actually to this day, this is still kind of an empty region. Okay, super quick. This is the remains of this telescope. Eventually, all these structures had to get blown up, et cetera, and filled itself in. Very quickly, VRAO telescope, 120 foot. Swenson actually became, Swenson was a builder, not a user. And after he finished building that 600-foot telescope, he actually took a 4-year leave of absence to go work at NRAO. As Miller has indicated this morning, NRAO was very well aware of interferometry issues, or they should be looking at interferometry. Swenson went there and was actually leading the VLA design group for 4 years from 1964 to 67. Then he decided he was going to build a 3-element interferometer, which was largely like Cambridge. Of course, actually at that time, lots of other big telescopes like we just saw earlier, and the Algonquin Park 46-meter telescope was coming into operation. NRAO 140-foot telescope was coming into operation. And so this telescope really, I would say, I'll say it was actually a mistake. Although actually I noticed, I was actually Googling something else last night, and it said that if you never make a mistake, you've never actually done anything in life. So. Anyway, John Weber, I worked a lot with him on this telescope. John Weber didn't get tenure because he actually didn't publish enough, and he liked messing around with instrumentation. So actually, appropriately, he became later head of the NRAO Central Development Lab, as probably some of you know, and did a very good job there. So I worked with him quite a bit on this. This is the way this thing looked. I would argue that one of the things which really made it not very useful, it had very limited coverage, plus or minus 2.5 hours an hour angle. And you could only really go down to about 7 degrees declination or so, which made it not very useful for studying stuff near the galactic center, which was really important during the late 60s, early 70s, when as was mentioned in one of the talks earlier, everybody wanted to discover interstellar molecules and get press releases about origin of life and this sort of thing. It's a residue of Swenson's goal to make this part of an element interferometer. This is the only fixed telescope I know which is mounted on wheels, because eventually if there had been a 3-element interferometer, you'd pull this thing along a sort of a gravel track, and plug it into locations, kind of like you do with the VLA. I just want to finish up with essentially this is one more. Okay,
you're done.
I'm done. Okay. One thing.
We burned through questions hard. You have to make this your last.
Okay, last thing. George Swenson was responsible for me going to the Westerbork telescope because, as I mentioned, he got involved in all sorts of stuff with aperture synthesis, and he obviously got on the mailing list for what was going on at the Westerbork telescope. And so one day in late 1971, this thing turned up in the radio astronomy living room. I was just amazed because in the previous slide I didn't have time to show, it was kind of a sample of what you saw with radio emission from normal galaxies in the mid-60s. When this thing came out, it was just amazing. So I got a fellowship to go there. And so I would have never probably thought about Westerbork if this thing hadn't plopped up as a result of George Swenson being involved in radio interferometry. So thank you.
Thank you.